All right, so this is our first video of continuous learning. We are going to be reviewing 8.4 and learning a little bit about 8.5, which deals with the E and LN notions in our calculator and how to solve for them. So our first thing we need to remember is how can we transform a logarithm into exponential form? So if we remember that log base b of n equals p, we need to remember it is equivalent to base p of exponent p equal to n. This helps us solve for logarithms. We can remember that by looking at log 3 to 81. And it's asking, what power of 3 makes 81? Well, the answer is 4. And the reason is because log 3 81 equals 4, it's because 81 is the same thing as 3 to the 4th. And that helps us remember what is going on. So make sure to remember going from logarithmic to exponential and vice versa. That helps us get through the rest of this. We also need to remember a log that doesn't show a base, so it's invisible, there is no base. It means it's the same thing as 10. 10 means there's an invisible one. So just like here, this says so log no base, which means 10 of 1,000. This means log 10 of 1,000. This is just invisible. It's that mathematical shortcut that mathematicians do. We like our shortcuts. So we know log of 1,000 equals 3 because 10 to the third equals 1,000. So remember, we can always go from a base to an exponent, and that's what we're looking for in our logarithms, okay? So we're going to move on to examples. Our first example says we need to convert log base 2 of z equal to 7 to exponential form. So to do that, we take our base, 2, exponent of 7, and it is going to equal z. So that says 2 to the 7th equals z, which also means if you know what 2 to the 7th is, which is 128, you have solved for z. You don't necessarily have to do that every time, but if you know how to simplify exponentials, go for it. Our second example is we're going to convert 5 to the exponent of x equal to 40 into logarithmic form. So we need to make sure it has a log. 5 is our base. So we need to make sure that when we do log 5 is our base, 40 is what our this value is, and we know it equals x. Well, we don't know how to quite solve that yet, so we're just going to leave this alone. But you have converted exponential to logarithmic form. So now we also need to remember to evaluate. So evaluation actually is looking for a solid and complete answer. So number 3 says log 1 over 100. It has no base, so that means base is 10. So this is saying log of base 10. We also need to remember, what do fractions mean? Well, fractions means negative exponents. So we need to find 1 over 100 to a base 10 with an exponent. Well, we know 100 is 10 squared. But because it's a fraction, it's 10 to the negative 2. Once we've understood that 10, 10, and 10, base 10s, our answer is our exponent. So answer to number 3 is negative 2. When we evaluate number 4, well, we have a base of 36 and 6. Well, we can't change 6 to be a 36, but I think we can alter our base 36 to help us out. So we can transform our bases, this one specifically to 6 squared, and we still have a 6. Well, this is a little awkward. It's different. There are 2 ways to solve for this. What you can understand first is if we can say this is equal to x, we can use our transformations from logarithms to exponentials. So this is going to say 6 2 to the x equals 6. We can now solve by knowing that those are the same base. So this becomes 2x equal to, remember there's an invisible one there, and we can solve for x. So x equals 1/2. This is how you do it, but we technically didn't have an equal. So how you understand that is when you look at the log 6 2 to the 6th, I will move it over here, log 6 2 to the 6th, there's a 1 here. Normally we need log 6 and 6, right, to say it goes away. So what it says is we take the top number and the base number, and we will get our answer of 1/2. So that was just our quick review of 8.4, and we're going to now move on to 8.5, E and LN. So these are very important. They help us do interest, compound interest, all sorts of stuff, and real world examples that we will not be getting to. Okay? So first things first is I highly suggest you have your calculator. If you do not have your calculator, there is a TI-84 app that you can download now on your iPad through self-service, especially if your calculator may be dead or potentially does die. Please download that. It is an app on your iPad. But first, E. We need you to find the E button on the calculator. There are 2 places to find this. So second divide is one place, and I would like you to take a minute now and figure out what is the value of E. So again, this 2 places to find this is second divide, that's our 1 value, so the second button, and our division, and you can see E, okay? And we want to know what the value is, so just press enter. Well, you should be getting a value about 2.718, and it just goes on. Okay? The other place to find E is you do second, the second button, and LN right below log. That should get you E, and it has an exponential spot. But for this one, you need to put in an exponent. And if you put in E to the first, you should still get 2.718, and it still would continue. The important thing you need to understand is E is an irrational number. It is very much like pi. It is called the natural number or Euler's number. It is used a lot for specifically our natural logarithms. It is the base of the natural logarithm. Natural logarithm is ln. So what that means is ln of x equals 2 is understanding that this invisible base for ln is e. ln of e of x equals 2 means the same thing if we convert from logarithm to exponential of e squared equal to x. So this just allows us to see in different forms, especially with natural log and our e value. These are very important and will be used in future lessons. All right, almost done. So we now need to use converting logarithms to exponential equations. Well, sometimes you're going to get an ln, sometimes you're going to get a log. Understand that ln always has a base of e, and logs could have a base of 10 or any other number under the sun. So if we look at number 5, we want to convert this to exponential. So understanding that this has a base e, we need to say base e of x equals 5. Okay? If you have any questions, please make sure to email me at any time. But this is your answer. You've converted from a logarithm to an exponential. Okay? 6, we now have a logarithm, not a natural log, with an invisible base of 10. So we need to convert it. So we take our base, 10 to the negative 1 equals A. If you see 10 to the negative 1, you should be able to solve it. So 10 to the negative 1 is the exact same thing as saying 1 over 10. If you do look at number 5, you cannot technically solve for x yet, so do not worry about it. We are just getting in the transformations. On number 7, once again we have an ln z equals 3. We have a base of e. So to transform it, we take e to the third, and we know it equals z. You can plug this in your calculator now. You can plug it in. If you plug in e to the 3, you should get approximately 20.09. But since we're just asking for conversions, I am just looking for that, because that's just solving for a variable and we are just asking for conversions. This one has a base of c for logarithm. So we say base c to the exponent of 2 equals 17. You could solve for c. You could square root it, right? And then no, c equals plus or minus the square root of 17. But once again, we are just converting, so the answer is technically c squared equals 17. But understand, you can solve for variables this way. All right, we only have 4 more problems to go, and we are going to convert from exponential to logarithm. And then this lovely lesson is over. Last 4. So we're now in exponential equations, and we're going to transfer them into logarithm. So all of them should have log, or natural log. So before you even begin, if you have a e base, you should be using ln. Here's an e base, so this should be ln. All others are going to be logarithm. Okay? So make sure you remember that. ln goes with e, no matter what. It does not go with log. So our first number 9 says e to the x equals 20. Well, since it's an e, once again, we know it has to be ln, base of e. Since this is our exponent, we know this has to equal the exponent, and what it equals is 20. So this is what it is. But understand that, do we need that e there? No, so your answer can be just left as ln of 20. Once again, you can plug that in your calculator. You plug in ln of 20. So you just go to the ln button, put in 20. You should get approximately 2.996. We are not asking for variables. We're just getting you into conversions, but future reference, we can just plug them in our calculators and get approximate answers. So number 10 has a base of d. Since it's not e, we know it has to be log. So we do log base d. Again, our exponent is what we have to equal. So our h has to be here. So log d of h equals -5. You are understanding so far. I'd like you to take the time to do these other 2 and then check your answers with me in just a moment. So go ahead and pause your video. Should be doing that throughout just so you can see how well you're doing, but again, first lesson. So 11, we have a base of 10. So what that means is we have to have a log, because it's not e. So we take log base 10. If you have a base of 10, it can be invisible. It doesn't have to be written there. So we say log of base 10. Remember, our exponent is what it equals, and we can say log 15. So log invisible base 10, 15 equals q. Because this one has a 10, you can technically solve for this, but we'll go more into that in detail later. All right, our last problem for review today. Number 12. We have a base of e. Therefore, we must use ln. So ln, invisible base e. We know it has to have another n, because it has to equal our exponent of 4. So ln of n equals 4. Okay. Well, this was review of 8.4 and the beginning of 8.5 E and LN. If you have any questions, please feel free to email me at any point in time, and I will give the next one up and going.